video will recap solving quadratics and solving polynomials in general. I'm going to use this little puzzle set, Did You Hear, which is in your notes. And as you can see, each of these, they're all quadratics, meaning they're all degree 2, which means that you can have at most 2 real number solutions, meaning you could have no solutions, 1 solution, or 2 solutions, but you would never have more than 2 solutions. So when you're solving polynomials, when you're solving quadratics in particular, make sure that you always set the equation equal to 0 and arrange it in standard form. So standard form means to line it up in order by exponent. So I've chosen to do a few on the video just as a little review, a recap for you. I'm going to do letter H first. So here's letter H at the top, and I'm going to do this first. So notice that it's not in standard form. So I'm going to subtract 9x from both sides, and I'm going to make sure that I place 9x in the correct spot when I bring it to the other side. So now this is arranged in standard form, and I would do my big X factoring. I need factors of 20 that sum to -9. That's going to be -5 and -4. And to go through the steps with factor by grouping. And then I would introduce my parentheses in, reverse distribute out the X, leaving you with 2x minus 5, and then I would reverse distribute out a -2, leaving me with 2x minus 5. And so here are my 2 factors. So notice that the ability to factor quickly and correctly is really important for solving, because that's how you solve. You need to look at the polynomial in its most factored form, and then you set each factor equal to 0. So x plus 2 equals 0, or x minus 2 equals 0 rather, so the first root is +2, and then 2x minus 5 equaling 0, so the next root is solving this two-step equation by adding 5 and dividing by 2. So my 2 solutions here are +2 and +5/2. And looking for that answer in the answers that are chosen, or the answers that are given, you can see that that is a solution set. So the puzzles are good for learning, just to verify that you're doing it the right way. I'm moving on now to letter D. And in letter D, I first went to do this incorrectly. So it's tempting to see this and to think that the right thing to do is to divide the m out of both sides, since there's a common m to both sides, leaving you with m equaling 11. But that is not the correct way to do this problem. Make sure that you always set equal to 0 first. So I would subtract 11m from both sides. And this is not a big X moment for looking for factors of a certain product that sum to that product. This is just GCF factoring. So reverse distribute out the m, and then you set each individual factor equal to 0. So the GCF m that was removed, the value of that, if this m is 0, then the entire product would be 0. So that's why 0 becomes the first member of your solution set. And then you set m minus 11 equal to 0, m is +11, so your 2 solutions are 0 and 11. Moving on to letter J, I've chosen this because this is the difference of squares pattern. This could also be solved by the square root method, and that's a method that we will explore second semester. So once again, I'm going to set this equal to 0. I recognize that it is a pattern. So it's going to be 3x or 3y, 3x plus 4, 3x minus 4, and make sure you've always set it equal to 0 because it is an equation. Keep it an equation as you're solving. And then you set each individual factor equal to 0. So my first solution, solving that two-step equation, I would subtract 4 and divide by 3. And then the second solution or root, I would add 4 and divide by 3. So my solution set is going to be positive and negative 4/3. And I would like for you to be comfortable with that notation. It's just implying that you've got the same number and its opposite in your solution set. And then the last problem that I'll do on the video for this particular problem set is choice E. And I've chosen this because I prefer to keep the lead coefficient positive. So in a problem like this, I'm going to add x squared to both sides. 9x is already positive, and then I'm going to add the 18. And now I'm looking for factors of 18 that sum to 9. And that's going to be 6 and 3. So I'm going to have x plus 3, x plus 6, setting that equal to 0. And my two roots are -3 and -6. And the order in which you write the roots does not matter. It's just a set of numbers. But I consider this problem set just basic solving skills. You need to be able to factor, and you have to have the basic understanding of the zero product property, which states that if a product is in fact zero, if an equation is in fact set equal to 0, then it's implied that one of the numbers in the product must be 0, because anything times 0 is 0. So this is just reinforcing the basic foundational understanding of the zero product property, arranging in standard form, the ability to factor, the fact that the degree of the equation is directly related to the number of roots or solutions that you can have. Moving to the next problem set, the equations are of degree higher than 2, so I wanted to work through a few of these with you. I consider this the next level of understanding, so I've chosen a few of these to do. And just looking at these, you can see that they're all of these are, all of these are raised, have a degree that's higher than 2. So that means that just perusing the solution set here, you can see that the solution sets all have 3 members. Here I have 2 members in the solution set, 3, 3. So the number of solutions is directly related to the degree of the equation. So here I've chosen to do letter G, the very first equation. So letter G, I've copied it. I haven't made any mistakes in it. I look for it, first of all, it's arranged in standard form by power 3, 2, and 1. I'm going to remove the GCF of n, and when I reverse distribute out the GCF of n, then I'm left with a nice simple quadratic to solve. And here I'm looking for factors of 12 that sum to 8, so that's going to be 6 and 2. So notice that I've got 3 factors to go with my degree 3 equation. I set each factor equal to 0. So my first solution is 0, my next solution is -6, and then my last solution is -2. So 3 solutions for a degree 3 equation. The next problem that I've chosen to look at on the video is letter I. And here's letter I. So letter I, I've copied the problem. It's not in standard form, so I'm going to arrange it in standard form. I'm going to subtract 14u from both sides, 14u squared, subtract 32u, set this equal to 0, and I'm going to reverse distribute out the additional u, and that's going to leave me with a nice little quadratic for solving. And I need factors of 32, 32 is negative, factors of 32 that differ by 14 units, and that's going to be 16 and 2, and 16 is going to be negative, 2 is going to be positive. So I have a degree 3 equation. I'm going to have 3 members in my solution set. The first root is 0, the second is +16, and the third is -2. And I'm getting my solution set by setting each individual pre-algebra expression equal to 0 and solving. So that's letter I. The next problem that I would like to look at is letter T. So letter T is a degree 4 equation, and this may look familiar. I can't remember if this is the one that I put on the last quiz or not, but this actually factors in the first round as a difference of squares, a pair of difference of squares. So here I need factors of 36 that sum to -13. So even though this is not a quadratic, it's quadratic-like in its format. So I can at least find my factors by imitating solving a quadratic. So here I'm looking for -9 and -4, summing to 13, -13, and if you multiply them, the product is +36. And the first member of each binomial factor is x squared. X squared times itself will generate x to the power of 4, and then I have -9 and -4. And if you were to multiply that out, the term in the middle would be a squared term. But notice that each of these factors is a difference of squares, which can unpeel one more layer. So this is x plus 3, x minus 3, x plus 2, x minus 2. So my solution set has 4 numbers. It's going to be positive and negative 3 and positive and negative 2. And I like these problems for learning because it just shows you the difference between a linear equation and an equation of a higher degree. So notice I've got 4 real number solutions going along with a degree 4 equation. And the last problem that I've chosen to do from this particular problem set is letter H. And so here's letter H. I've copied it exactly the way it's presented. The lead coefficient is negative, so I'm going to add 6x cubed to both sides. Setting it equal to 0 first. Look for the GCF. There is an extra x across the board. And when I reverse distribute that extra x out, I'm left with a nice quadratic for solving. And here it's factors of 30 that sum to 17. So that's going to be 15 and 2. And then set yourself up for the factor by grouping. So I'd have 6x squared, 15x, and remember it doesn't matter who comes first in the arrangement. And then introduce your grouping symbols in. So grouping together, and the x is sitting on the outside, just waiting. And in the first pairing, I reverse distribute out a 3x, leaving me with 2x plus 5. And I reverse distribute out a 1, leaving me with 2x plus 5. And then my final answer becomes the 3 binomial, or the 3 factors. X moves down, and then I'll have 2x plus 5 and 3x plus 1. So my 3 solutions for this particular equation will be 0, negative 5 over 2, and negative 1 over 3. 3 real number solutions for a degree 3 equation. And the last thing that I would like to look at on this video, I'm going to go back to this problem set, moving words. And it's very, this is very, very basic, very easy, nice learning set. But what I would like to do is look at this problem set in the reverse. I would like to look at the solution set and work from the solution set in the opposite order to arrive at the binomial factors, and then multiplying the factors together to get the original polynomial, or quadratic in some cases, to get the original equation, or the equation for which these are the solutions. So this is another little skill, another little technique, and I've copied a few of these solution sets down. So I've taken a few from the first column, and let's look at that first. Looking at the solution set, positive 2, negative 1/3, if you think about the most basic binomial for which positive 2 would be a solution if it were set equal to 0, it would be x minus 2. And if you think about the most basic binomial for which negative 1/3 would be a solution if that binomial is set equal to 0, this would be positive 3x plus 1. Solving this, x minus 2 equaling 0, x would be positive 2. Here, when the root is a fraction, the first move in the two-step equation is to subtract the constant, and then you divide by the coefficient. And then notice that the root has the opposite sign when you compare it to the operation in the binomial factor. And then if the instructions ask you to give the original quadratic or the original equation that was used, the first thing you would do would be to arrive at the factors. Then you would multiply the factors together, and you would get 3x squared plus 1, that's going to be minus 5x minus 2 equaling 0. So it's just a little technique working in the reverse. Moving across, I chose the very next column. So here I have 2 fractional roots. So my first binomial factor would be to, let's see, the last move would be to divide by 2, so that means I'm going to start with 2x. I added 5. Since this is positive, that means my operation is going to be negative. And then the other binomial factor, I would start with 3x, end with 1, and since this is negative, that means I would be adding the 1. I would be adding those 2 together. And if you were asked to find the original equation, you would just simply multiply this out. So you get 6x squared plus 2, that's going to give you minus 13x minus 5. So this would be the solution set for this equation. And I've chosen this because this represents our little pattern. So this would actually be the solution for 9x squared minus 4 equaling 0. And if you were to factor that, you would have 3x plus 2, 3x minus 2 equaling 0. This is your difference of squares pattern solution set. Let's look at this example. This is in the third, actually in the 1, 2, 3, the fifth column now. But I've chosen this because it has 3 members. Actually, let me move over a little bit. Let's do the 2-member set first. So here, this is from the first column. If I have a root of 0, that's implied that I had a GCF of x, or a multiple of. And then the mate would be 4x minus 7. Since this is positive, that means the operation inside the binomial factor is subtraction. And then to multiply that out, this would be 4x squared minus 7x equaling 0. This is the solution set for that equation. Looking at the next, I've chosen 0 and 9. So 0 will be the solution for just a GCF of x. 9 would be a solution for x minus 9. So my original equation would have looked like this, or it could be a multiple of. It could be 2x squared minus 18x. But it would, factoring it down, this would still be the solution set. Looking at the 3-member solution set, this would be x, and then x minus 2, and x plus 1. Setting that equal to 0, and then multiplying all of that out to get a cubic. And then I've chosen one more 3-member solution set. I would have x, x plus 14, x minus 1, setting that equal to 0, multiplying all of that out, and arriving at a degree 3 polynomial. So that's just your basic skill of factoring, solving by factoring rather, and then looking at the solution set working in the reverse.